So I just want to touch on one last thing about 16 is you notice how the horizontal asymptotes at -1 and the vertical asymptotes at -4. The easiest way to do this is to say, okay, we're dealing with, I don't know if it's distorted. We can put in a number later on. Usually you would put in a constant here, but let's just skip that and just assume we're dealing with something basic. And this would be the vertical asymptote, okay, x -4. And if we want to do the horizontal asymptote, we just do this, -1. But you'll never see a reciprocal function like this in existence. So what we want to do is turn this 1 into something that's x plus 4 over x plus 4. And what's equivalent to 1 with x plus 4? Well, it's x plus 4 over x plus 4, like this. So that means we can replace the number 1, because it's the same thing, with this. Now that its denominator is the same thing, we're really talking about this. This over here, this over here, because we've made the denominator the same. When I resolve that, this minus goes into minus x and -4, so you get minus x -3. And of course, they don't like to see that, so the constant you'll see in front is -1, x plus 3 over x plus 4. And sometimes you'll even see that minus in the textbook just right up front, like this. And that's the equivalent, believe it or not. That is the same. I'll put the minus closer. That is the same as that on the left. These are the same functions. You wouldn't know it to look at it, because it looks very different, doesn't it, than that? But if you punch them into your calculator, you'll see that they are indeed the same. The last step that you should actually do, though, is you should find a point, and we don't really have a good point here. We do have this one, -3, comma 0. So that should fit into this equation. When I put in -3 here, I should get 0. And sure enough, when I put -3 in x, this becomes 0. The whole thing will become 0. So we know that there's no constant in front. If it didn't come out 0, we'd have to make it equal to 0 and figure out the constant. And that's how you do it, to figure out constants in front. And there you go. Moving on to the next chapter. So the next chapter is chapter 5.1. And its point here is how to figure out different horizontal, to figure out holes, to figure out horizontal asymptotes, and a new one, an oblique asymptote. Oblique asymptotes happen when the power up above is bigger than the power down below. Let's say you have x cubed plus 4 at the top, and you have x squared minus 2 at the bottom, like this. Because the power up cubed, because the power up above is bigger than the power down below, we have an oblique asymptote. An oblique asymptote is something that will be like this, and I'll show you in the graphing calculator. But how do we, here we're going to start by figuring out the oblique asymptote. And what you do here is you go back to an old school technique called long division. And you divide x squared minus 2 into x cubed. I'll keep a copy here. Into x cubed plus 4. So ask yourself, what do I have to multiply x squared by to get x cubed? Well, it's an x, right? I have to multiply it by an x. So I put the x up here. But I'm putting it here as well to show you. So I get x squared minus 2x. So x cubed minus 2x. So there I do that, and minus 2x. And now with that plus 4, here's a little thing. I should have made it 4x. I might as well make it 4. Let's make it 4x here, just for simplicity. 4x. And then when I subtract these, this 4x becomes minus 2x, so it becomes 6x, and x squared cannot go into 6x. So the remainder doesn't matter. We just know that this asymptote will be y is equal to x. Let's see if that's true. So we got x cubed plus 4x over x squared minus 2. Okay, now I'm going to put in the formula for the oblique asymptote. And then when we zoom out, we can do indeed see that these red lines do indeed hug that blue line. So that is indeed the formula for the oblique asymptote. Now, notice that even if I not put the x in here, it would still be the right formula. Also notice that sometimes the red line will cross the oblique asymptote once, not twice, just once. And you can always figure that out by making this formula equal to x. And when we do that, we have to get rid of the denominator. So when we multiply it over here, we get x cubed minus x. Then we have to put everything on the same side. So when the x cubed goes to the left side, it disappears, and we get x plus 4 is equal to 0, which obviously is when x is equal to minus 4, equals minus 4. So then we go back to the original formula, and we put in minus 4 for x. So I'll just make this f of x to make it easier. And we get this, minus 4 comma minus 4. So we get minus 4 comma minus 4 is the time that this formula will cross the is the only time that this formula will cross the oblique asymptote. Sometimes it's on this side as well. Sorry, I shouldn't have said one time. I mean one time on one side. And there you go. That's oblique asymptotes. This technique works every time. The remainder does not matter. So now knowing that, let's get into the chapter. Now I'm not going to do, and a hole appears when the bottom cancels out for the top. Now I'm not going to do all of them. I am going to do all of them for number 1. The secret to matching one with a formula with an image is to focus on their asymptotes. So even looking down here, notice that this one has 2 asymptotes. Everybody else has 1 or a whole or none at all. So the only one that could have 2 asymptotes is this one right here. It's the only one with 2 things on the denominator. And when I match it, I do indeed see, yeah, at 1 and minus 3 is the asymptotes, which matches this even more. So that's one tricky way to do it. The other one is to notice that this one over here is always positive and has no asymptote. And the only time that can happen is if you have an x plus something squared. And it cannot ever get above a negative. It cannot create a negative number. Now, all of these can create a negative number because this is a negative and this can become a positive. This can become a negative and this can become a positive. And this one over here is also always positive. So notice that there's 2 that are always positive, this one and this one. So this one over here might have an asymptote. To do it, we solve the bottom. We make the bottom equal to 0, and we discover no, it doesn't. X squared plus 5 is equal to 0. X squared is equal to minus 5. It cannot have an asymptote. So right away I can say that one's going to go over there. And then we just got to figure out if the other one has an asymptote, just to make sure, right? So we go to this one, the only other one, and we set the bottom to be equal to 0. So we start by square rooting both sides. Gets rid of it. Then we discover x is equal to minus 3 is the possible asymptote of this one. And sure enough, this one right here, which is always positive, is also got an x is equal to 3 asymptote. So right away, we can put that one there. So we've gotten rid of this one. We've gotten rid of this one. Which one else did we got rid of D? And we're just left with these. These are just going to be basically finding the asymptote. Oh, we got rid of this one too. Yeah. Wait, we should have 3 left. So I deleted a wrong one. Yeah, I deleted the one at the bottom by mistake. There we go. And then C squared minus 3. No, yeah, that one should go. I deleted 2 by mistake. I deleted this one by mistake, I think. 5. That one's minus 3. Because this one's squared, it's always positive. And this one's squared, it's always positive. There we go. X squared minus 3. Well, this one has This one has a very simple asymptote. It can't cancel with the top. I would just look for x is equal to 3. So there's this one. And there's this one. So I have to be careful. And the bottoms are all solved for. When I look at this one, though, This one is not going to have an asymptote. That's because the top factors into x plus 3 and x minus 3. And the x minus 3's will cancel out, leaving a line, y is equal to x plus 3. This is the only line here, and it's going to have a hole at 3. And sure enough, they've drawn a hole here. You can't quite see it. So that one has a hole. When the denominator cancels out with the numerator, the restriction still is x cannot be 3, but it's going to be a hole. So that means this drawing over here is this one. And then finally, we got 2 left. They both have an asymptote of 3. We just have to figure out which one's which. Well, we can figure out which one would cross here. You see it cross. It looks like it crosses into 0, 0. And this one does not. This one has a horizontal of y is equal to 0. This one does not. So let's see. The denominator determines where it crosses the x-axis. If I set that, and where does it cross the x-axis? When y is 0. So if I set that whole thing, I'll show you how it's done. If I set that whole thing equal to 0, the first thing I have to do is get rid of that denominator and multiply both sides by x minus 3. 0. X minus 3 multiplied on this side will cross out the denominator. X minus 3 on this side will just be 0 again. So it's like not even, the denominator doesn't even matter when I set it to 0. So really we're dealing with like this. When does x squared equal 0? When x is equal to 0. And when x is equal to 0 in this formula, y will be equal to 0. So that means this one here belongs to that one. That's how you figure it out. If you didn't, you could just, punch in some points and see which one comes out with those points. You could try to figure out the horizontal asymptote. Why is this higher? You could do all sorts of things. You could just plug in some numbers like 5 and see where this comes out as, and see where this comes out as, and see which one matches the drawing if you got stuck. But we've already determined that this one matches this one, and therefore this one matches this one, and that's it. That's all there is to it. You just got to study them a bit and learn which ones are always positive and figure out what happens when it's always positive. Okay, moving on. I'm trying to do these quickly. This one I'm not going to do all of them. Instead, I'm going to show you the 3 things we should be looking for. Okay. Okay, good enough. To figure out a hole, these are 3 things they're asked to look for. The horizontal asymptote. Verticals are easy. Horizontal asymptotes, y will be equal 0 when the top is 1 or a lesser degree than the bottom. So let's just spot which ones will have y is equal to 0. This one. That's the same. This one. Those are all matching. That's that. This one. Those are the 3 that have y is equal to 0 because the top is 1 or a degree that's less. Notice that this is x up here, but this is x squared down here, which means y is equal to 0. We can easily figure out this vertical asymptote by setting it to equal to 0, and we discover that x is equal to 4 or minus 4. How do you do that? Well, you make x squared will equal to 16, but when you take the square root of both sides, as soon as I take the square root here, I have to take the square root here and add plus or minus. That's because the square of minus 4 is 16, and the square of 4 is 16, so it's 2 possible outcomes. So that means the vertical asymptote will be at x is equal to 4 and x equal to minus 4. But let's factor that. That's a difference of 2 squares, and notice the top. Notice the top has an x plus 4. The bottom factors into x plus 4, x minus 4, and cancels with the top, which is x plus 4. So right away, we're left with these will cancel. That means at x minus 4, there's a hole. We're left with this. This is the final thing, but there's going to be a hole at x is equal to minus 4. And we can plug it in and figure out what that is. Yeah, it's going to be 0, minus 4 comma 0. And there's an asymptote at x is equal to 4. And the horizontal asymptote is 0. There you go. That one has a hole. This one, the vertical asymptote is x minus 3 and x equals 5. This one, the vertical asymptote is x is equal to minus 3 over 2. Just set that to equal 0 and solve for x. So those are the ones that have zeros. Y will be equal to a specific number when the degrees match, top and bottom. Okay, so let me group the ones where the degrees match. This one, the degrees match. This one, the degrees match. This one, the degrees match. Gonna need more room. This one, the degrees match. This one, they gave a lot of degrees matching so that you could figure out them. This one, the degrees match. This one, the degrees match. And wow, they have a lot of them, the degrees match. And this one, the degrees match. The secret with this is you ignore the x and you figure out the number in front of them. So this has a 1 in front of it, and this has a 1 in front of it, and you divide them. 1 divided by 1 is 1. So that horizontal asymptote for this one will be 1. You can plug it into graphing calculator if you want. This has a 2 in front of it, and this has a 1 in front of it. So the horizontal asymptote for this one will be 2. 2 divided by 1. This one has a minus 1 in front of it. That's just an equal sign. And a plus 1 in front of it. So minus 1 divided by 1 is minus 1. So this will have a horizontal asymptote at minus 1. This one has a 1 in front of it and a 5 in the bottom. So the horizontal asymptote is 1 over 5. I'm not going to go into the verticals. The verticals are very easy to figure out. This one has a 3 over a 1. So the horizontal asymptote is 3. This one has a minus 4 over a 2, so the horizontal asymptote is minus 2. This one has an 8 over 4, so the horizontal asymptote is 2. And this last one has a negative 3 over 2, so the horizontal asymptote will be negative 3 over 2. And that's how you figure out the horizontal asymptotes. The vertical asymptotes, you just set the bottom to equal 0. So there's going to be 2 vertical asymptotes. 1 minus 1 over 4. We already figured that one out. 3 over 5. 4. 5 over 2. 2. Minus 1. Minus 3. 6. Minus 3 over 2. And minus 4. Now let's focus on the next one. Oblique. Oblique. Obliques exist when the top degree is higher than the bottom degree. So let's spot our obliques. This one. That one's going to be a tricky one. Not many. They didn't give us many obliques. Is that the only one they gave us? Yeah. Okay, so there's just one oblique. Notice that it factors on top to x minus 3, x plus 3. And that means the x plus 3's cancel out, which means there's a hole. There's a hole at x is equal to minus 3. All holes exist when they cancel out. And really, we're dealing with this line. Y is equal to x minus 3. So it'll look like a line. Y is equal to x minus 3, where there's a hole at minus 3. It'll be minus 3 comma 0 will be the hole. And it'll look like a line. And now we don't need to calculate the oblique asymptote because this line happens to be the same as the oblique asymptote. So there you go. There's that. Write an equation with rational functions. These you just invent. So if I want a hole at x plus 1, that means x minus... I don't know why they do this. I guess it's just to think backwards. So if I want a hole at x minus 1, that means I have to have x minus 1 at the bottom, or at x1, I have to have x minus 1 at the bottom, and x minus 1 at the top, and then I can just add anything so that those cancel out, and I can just add like an x. So those will cancel out, and I'll be left with y is equal to x, but this formula is fine for creating a hole at x is equal to 1. A vertical asymptote anywhere and a horizontal asymptote along the x-axis. That would be y is equal to 0. So that's very easy. So we notice that anything with 1 has a horizontal asymptote of y is equal to 0. And then we can just put anything down here for a vertical asymptote there. That will have y is equal to 0 and a vertical asymptote. A hole at equals -2, it looks like, and a vertical asymptote at 1. Okay. To create a vertical asymptote at 1, we need an x minus 1 at the denominator. To create a hole, we need an x at -2. We need an x plus 2 at the bottom and an x2 plus 2 at the top. This is good enough right here. This will cancel out, creating a hole, and I'll be left with 1 over x minus 1. There'll be a hole at -2, 0. A vertical asymptote at x minus 1 and a horizontal asymptote at y is equal to 2. Okay, so to create a vertical asymptote at x minus 1, on the denominator I need x plus 1. To create a horizontal asymptote at y is equal to 2, I must use the same degree as down here and make sure that the number in front cancels or divides by the number in front of this and creates a 2. So right there, 2x over x plus 1 will create a vertical asymptote of -1 and a horizontal asymptote of y is equal to 2, because 2 divided by 1, the coefficient in front of this one, will create y is equal to 2. And then an oblique asymptote with no vertical asymptote. So that's quite simple. Oblique asymptote just means that I will have a degree that's higher than the bottom. So let's just start with x squared up here and x down here. And that one right there won't have a vertical asymptote because the x will cancel out and create y is equal to x with a hole at x is equal to 0. But even if I didn't want a hole, what I could do is just say, okay, if I make this plus 2 and square it, that will no longer have a hole. Just be aware that I've made this degree 2 now with that square. Sorry, it will no longer have a vertical asymptote. That will be a positive bump or a down here, but it is impossible to make that equal to 0. Let's see if that's true. Well, that's not entirely true. Let's do it slightly different. Let's make it x squared plus 2 down here like that. So right there, that does not have a possible solution to equal 0 down there, which means up here the degree just has to be higher. Right there, that will create an oblique asymptote at y is equal to x. Let's punch it in just to see. X cubed over x squared plus 2. Yeah, does this little wiggle. And we'll discover if I make y is equal to x. Sure enough, there's my oblique asymptote or diagonal asymptote. And it crosses it once here at 0, 0. And there you go. How did I know it would be y is equal to x? Because x cubed divided by x squared, it requires an x to make x squared x cubed. Therefore, if I were to do long division, I would get y is equal to x as the oblique asymptote. Moving on. Oh, those were just warm-ups? Oh, that's 5.2.